Okay, so take a look at that page. We're doing heat and change of phase practice problems. But why don't you do it on this page? So turn to page, what is this, 38. Okay, page 38. And this is like in addition to Q equals MCAT. So you already know what Q equals MCAT is, right? So you're going to be using that plus one more thing for these problems. So take a look at, and actually before we even do that, so on your worksheet, I want you to draw this, or let's entitle this total energy from phase changes. Okay, so yeah, jot that down. That's the title. Total energy from phase changes. And you can jot it down after number 3.
Oh, okay.
Yeah. These are just normal Q equals MCAT problems. Yeah. So I think that the best way to do this is to give you the big picture, and then we'll go over the specifics after that.
Okay.
Does that make sense?
Yeah.
So let's graph this first. And this is going to be important for visualizing what we're going to do. So draw a little graph there. We're going to label the y-axis temperature. Yeah, have this in your notes, temperature and time. Okay, temperature and time. Okay, so let's say, for example, I had an ice cube in my hand. Okay, and actually, let's say the ice cube, I'm going to put it on a hot plate, little thought experiment. Okay, turn up the hot plate to level 10. What's going to happen to it?
Melt.
It's going to melt, right? What temperature is that ice cube to start with?
Freezing.
Yeah, freezing. Do you remember what the freezing temperature is?
0 Kelvin.
Good. Or not 0 Kelvin. That's
0 Fahrenheit.
0 degrees Celsius. Yeah, 0 degrees Celsius. Celsius is based off of water. So 0 is freezing, 100 is boiling.
Okay.
But let's say this ice cube is special. I super freezed it. So it started off at -10. Okay, so -10 degrees Celsius. Can you see that? Yeah, okay, good. Okay, -10 degrees Celsius, 0 Celsius. So my ice cube, it starts off at -10, then it's going to go to 0 degrees, and then what's going to happen to it?
It's going to start melting.
It's going to start melting, right? It can't get higher than 0 because it's going to melt before that point. So I'm going to represent that by a plateau or a flat line. Yeah, that the moment I put that ice cube on the hot plate, heats up to 0 degrees Celsius, then it flatlines. Okay, this flat line represents it changing from solid to liquid. Okay, does that make sense so far?
Yeah.
Okay, after that, what's going to happen if I keep heating it?
It's going to keep on being a liquid.
Okay, it's going to be a liquid water until what temperature?
100.
Until 100 degrees Celsius. Which, by the way, in Fahrenheit, that's 212 Fahrenheit.
Okay.
No one remembers that. 100 is way easier to remember. Okay. Again, what happens to the liquid once it hits 100?
Starts boiling.
Okay, it's going to boil. So it's going to go from liquid to gas. Okay, liquid to gas, L to G. After that point, the steam can actually get hotter than that.
Okay.
Okay? Now let's graph it the other way. So notice it's heating up, right? So I drew it in red because it's heating up. The water, or the ice cube, is absorbing that energy. Okay? On the flip side, what if we did the opposite? What if I had super hot steam? Okay, what's going to happen once it hits 100 degrees Celsius?
So it's cool down.
It's going to cool down and turn into what?
Liquid.
It's going to turn into liquid. Good. So gas into liquid. Kind of the reverse. Okay, and then what?
Then it'll keep on going down until 0.
Good.
Turn into a solid.
It's going to hit to 0. Then it's going to turn from liquid to solid. And then from there, could even go a little bit colder, right? Could super cool it. Okay, so having your problems on your paper are either going to be one of these two examples. Either we're heating some water up or we're cooling it. Okay? So take a look at number 5. Look at number 5. So number 5 says determine the amount of heat needed to raise a temperature of 20 grams of ice at 0 degrees Celsius to water at 80 degrees Celsius. Okay? So where are we on that graph here? Are we the red one or the blue one?
You're the red.
We're the red one. Okay. We have ice, right? So that's it's still solid.
Yeah.
It's not liquid yet.
Yeah.
So we're right over here, and it's gonna turn into liquid, and then it's gonna go not to 100 but just to 80.
Yeah.
Okay. So this tells me that it's gonna be 2 steps. This is one step here, and then a second step there. So I'm gonna write my first step here. So yeah, do you need another? You might need some space, so maybe do it on another paper. You need another paper?
No, that's fine.
Okay. Or you can do it on that other, your packet,
Right on the side.
or on the back side. Yeah, back side's fine. Although you might wanna see the questions. I don't know if you're okay with it going back and forth.
Yeah.
Okay. All right. So here's one of the key points. Whenever we have a phase change, right, solid to liquid, liquid to gas, gas to liquid, liquid to solid, can we use Q equals MCAT?
Yes.
Why?
Because we're able to
Do we have a mass?
Yes.
Yes. Do I have the specific heat of water?
Yes.
Yes. Do I have a change in temperature?
Yes. Oh, no.
We don't have the change in temperature, right? Because it's flat,
Yeah.
right? There's no change in temperature. So because of that, I cannot use this.
Oh.
I can use this whenever there's a slope,
Yeah.
like for step 2, but I cannot use this for step 1.
Oh.
There's a different equation we use.
Oh.
So write down this equation. Okay, delta H, what we call enthalpy, or heat energy,
Okay.
is equal to delta H fusion, or it could also be delta H vaporization. Fusion or vaporization, good stuff, times mole. Okay, times a mole. Okay, you use fusion whenever it's solid to liquid or liquid to solid, whenever it has to do with ice.
So
We're
you got
fusing
the-
molecules together, you can think of it that way. Vaporization is obviously
When it turns to liquid to gas.
liquid to gas, or vice versa, gas to liquid. Whenever it has to do with gas,
Okay.
we use vaporization, okay? This number, delta H fusion, is a constant.
Okay.
Kind of like when we have Q equals MCAT, right? C is a constant, right? So this delta H fusion is always 6.01 kilojoules per mole, okay? And put a star next to that. It's always that number. Fusion is always that number. Okay, vaporization is always 40.7 kilojoules per mole. Always. So again, put another star next to that. Okay, the only difference is if we are going upwards on the graph, we're adding heat. We have to put heat into the ice cube, or the ice cube is absorbing heat. This number is positive.
Okay.
If we're going down,
Negative.
it would be a negative number, okay? So in our case, we're going to be using delta H fusion times moles. Okay, so let's rewrite that equation. How many grams did we say we had?
20 grams.
20 grams. How do I turn that in? How do I convert that into moles? 20 grams of H2O. How do I convert that? Okay, good. Yeah, look at your periodic table. Look at the molar mass. 2 hydrogens and 1 oxygen.
So 18.
18. Does that go on top or bottom?
Bottom.
Good.
And you have 1 mole on top.
1 mole on top. Very good. Okay, so let's calculate that. 20 over 18.
1.111.
1.11. Let's round to 1 decimal place. Okay, 1.1. Okay, so that plugs in here. Delta H fusion is a constant.
6.01.
So 6.01 kilojoules per mole multiplied, and it's a positive number because we're going upward on the graph, times 1.1 moles. Okay, so what does that equal to?
6.611.
We'll round it to 1 decimal place. 6.6. And what unit?
Kilojoules.
Good.
per mole.
Well,
just
the moles
kilojoules.
cancel.
Yeah, so it's
Kilojoules. Good. Okay, kilojoules. KJ. Very good. That's step 1. That's this part right here. Okay, step 2. Can I use Q equals MCAT?
No,
Why not?
because you still don't have the time. Oh,
Do I have a change in temperature for this leg where I'm raising it to 80 degrees?
wait, yeah.
There is,
You
right?
have one, yeah.
Good, yeah, so I can use Q equals MCAT. So let's plug in stuff for that. What is my mass?
Mass is 20 grams.
20 grams. What is the specific heat of liquid water? You remember?
Oh, specific.
And if you don't remember, look at the back of the periodic table. Right next to Q equals MCAT.
4.1.
Good, so it says liquid water. It's different if it's solid or gas, but for liquid it's 4.18 joules per gram degree Celsius. Okay. Remember that's how much energy it takes to raise 1 gram by 1 degree Celsius of water. So it takes 4.18 joules. And then change in temperature.
6.6. Oh,
Okay, nope. What is final temperature minus initial temperature? Which I look in your problem.
Oh,
Yeah. What did it end up at minus what did it start off as?
0. Start off at 0.
Okay, good.
Then goes to 80.
Good. So 80 minus 0. That's degrees Celsius. Or just 80, right? 80 minus 0. Okay, so let's calculate that.
Uh, 6,688.
Joules. Okay, let's round it again. So 6 point, or, you know what, let's leave it. Okay, good. So we got our 2 steps. Last step is to add them together. Can I add joules to kilojoules?
No.
No.
You have to make it kilojoules.
Let's make them both kilojoules, yeah, to be consistent. So how do I turn this into kilojoules?
Divide by 1,000.
Divide by 1,000, good. So I'm gonna divide by 1,000, move it over three decimal places. 6.68. Let's round it to 1 decimal place.
So 6.7.
6.7 kilojoules. Okay, so let's add them together. Step 1 and step 2.
13.3.
13.3 kilojoules. And if you look on the back of that worksheet, I have the answer key over here. So number 5, sorry, it's not number 3, 4, 5, 13.4. So that's pretty good. That's close enough. Okay, how did that feel?
Pretty easy.
Not too bad, right? We're just adding this stuff.
Yeah.
And it's really not that complicated of an equation. Okay.
It's just like you need to know the equation first and then you can figure it out.
That's right, that's right. Okay, so let's do the next one.
Number 6.
Yeah, number 6. Whoops. Okay, so yeah, let's read the problem. Find the heat lost by 20 grams of water at 40 degrees Celsius to form ice at negative 20 degrees Celsius. So which graph am I using this time?
You're doing liquid to solid. So
Good.
it's the right side.
This one, yeah. So I'm doing, starting off as what, 40 degrees.
40 degrees Celsius.
Okay, so there's one step right here because it starts off at 40, goes down to 0, and then what happens to it?
And then goes to solid.
Goes to solid, so
negative
that's step
20.
2, and then drops down to
Negative 20.
negative 20. So there's going to be 3 steps. So the graphs help because it tells us how many steps there are.
3 steps.
3 steps. Yeah, the max is 5.
Oh.
Yeah, and there's a 5 one I think after this one,
Oh.
but it'll be okay. Okay, so here we go. So let's do step 1. Okay, step 1. Which equation do I use? Delta H or Q cos MCAT?
Delta H. Oh. Yeah, delta H.
Okay, is there a change in temperature? Okay, let me do, right, we're starting off at 40, then it drops down to 0, then it drops down further to negative 20, right?
So it is.
So for this first part, what do I use? MCAT or?
MCAT.
Is there a slope or is it flat?
Slope.
Slope.
So
If there's a slope, I use Q because MCAT.
Oh, so and then if it's a line, then
If it's straight,
delta.
there's no change in temperature, delta H. So I'm using Q because MCAT. Okay, so let's plug in. What do we got?
So
Mass is
20 grams.
20 grams. C is liquid water still, so
4.1.
good.
8.
Good. And then change in temperature.
So it'll just be 40 minus.
Is the final temperature 40 or is the initial temperature 40?
Initial temperature.
Initial temperature, so it's going to be 0 minus 40. Okay, we're going to get a negative number, and that's fine because we're actually trying to lose heat take away heat from the place.
So you get negative 3,344
Unit?
Kilojoule, or joules.
Joules, good, joules, okay. Okay, good, that's step 1, pretty easy. Step 2. Flat line, changing it from liquid to solid, so
delta fusion.
delta H fusion times mole. Okay. We had the moles from the last problem, so let's just use that.
The 1.1.
Yeah.
Okay.
So delta H fusion is what number? That I plug in for there.
Oh, the 6.01.
Yep, 6.101 kilojoules per mole. And then how many moles?
6.6. Oh, 1.1. Sorry.
1.1.
6.6 kilojoules.
Okay, 6.6 kilojoules. Okay, good. And then step 3,
Q versus
Q equals MCAT, good. Because there's a slope.
So we just put in the same stuff in?
Almost. Mass is
20.
20 grams. C is ice now.
Oh, so 0.
Nope.
Oh.
Look at your periodic table. What is the?
Oh, solid. So 2.1.
Good.
08.
2.108 joules per gram degree Celsius. And then temperature.
Initial temperature 0.
Good. 0 minus
What? Negative 20.
negative 20. Oh, wait. Is negative 20 the final temperature or initial temperature? Remember, it's the final temperature
Oh, so
first.
then is it 40 again?
Well, just of this part right here.
Oh,
Starting is
0.
0, ending is
Negative 20.
negative 20. So the ending
it's
goes
0.
first, yeah. 20 minus 0.
Okay.
Yeah, always remember it's T final minus T initial.
So you have negative 843.2
Joules or kilojoules?
joules.
Joules. Okay, good. Okay, notice one of them is positive.
Yes.
Did we do this right? 6.01. Should that be a positive or a
Oh,
negative if
that
we're
should
going?
be a negative.
That should be a
It's going
negative.
down.
Good, so this would be a negative number. So notice all of them should be negatives or all of them should be positives. If you have a mixture,
Yeah.
you did something wrong,
Oh.
right? Yeah. So now let's add them all together. Oh, actually, should we add them all together?
No, make them all kilojoules.
Okay, so how do we
then
do that?
It'll be negative. Well, for the first step, it'll be negative 3.3. Oh, if one just put it at the first one, so 3.5. Well, 3.4.
Does the 4 round up or
Shoot,
down?
No, sorry, 3.4.
Yeah, you had it right. Okay, good. That's good. How about this one?
0.84.
Yep, good. Okay, now let's add all 3 of them. Grand finale. This is like my favorite part.
10, negative 10.74 kilojoules.
Okay, let's check our answer.
Oh, 10.9.
Ah, that's good. 10.7 is good. Okay, how do you feel?
Easy.
Pretty easy?
It's just,
Ready for the 5 step?
let's see.
Okay, try the next one on your own.
Okay, the 5 step.